Here I'm going to go ahead and do 3 problems which involve using the combined gas law. The first one's pretty easy, second one's a little bit more difficult, third is probably the hardest type of problems you could find. Okay, so first one, you say a gas has a pressure of 740 torr and occupies a volume of 2 liters originally. The volume of that gas is decreased to 1 liter at constant temperature. Find its new volume. So what I like to do here for these type of problems is I like to make a little chart with the initial conditions, and then a chart with the final conditions. So this is initial, this is final. So we say initially the gas has a pressure of 740 torr. So let me do that in a different color. Okay. And occupies a volume of 2 liters. And the volume of the gas, so the final volume is 1 liter. And it's asking you to find the pressure. Now, the combined gas law also has temperature, but luckily for us it says that it's changed at constant temperature, so the temperature doesn't change, so we don't even have to worry about this. So our combined gas law is just going to become P1 V1 equals P2 V2. Okay, and that is just for this problem. This is not going to work for every single problem, but just for this problem, since the temperature is not being changed, it says at constant temperature, we can just erase that part of the equation. Okay, so we're here. Original pressure is 740 torr. Original volume is 2 liters. Final pressure we don't know, so I'm just going to call that P2. And final volume is 1 liter. It's easy, just go ahead and do the math. I don't have a calculator with me and I'm not going to waste your time. Just 740 times 2 divided by 1 will give you the final pressure of the gas. Okay. A lot of these questions are about reading, so you got to be careful. Read the problem twice and make sure you have set up your chart correctly before going and actually doing the calculations. So for this question, a gas has a pressure of 1 atmosphere, volume of 3 liters, and a temperature of 25 degrees Celsius. Its pressure is decreased to 0.5 atmosphere and its volume is increased to 6 liters. Find its new temperature in Celsius. Okay, so originally our gas has a pressure of 1 atmosphere, so pressure is 1 atmosphere. It has a volume of 3 liters. And it has a temperature of 25 degrees Celsius. Here, very important, we cannot use Celsius in our calculations. We have to use Kelvin. Very important. If you end up using your Celsius, you will get these questions wrong. I remember my co-founder Zane did this on his first gas quiz. I told him specifically when I walked into the quiz, I was like, dude, you need to go ahead and remember to use Kelvin temperature. He didn't, and he ended up doing very poorly on that quiz. All because he just forgot one very simple thing, is that for any time, seriously, if you just want to go through your test even before you start and you see degrees Celsius, you remember you have to convert it into Kelvin. See degrees Celsius, when you walk into that gas test, honestly, you should put yourself in that mindset. Just be like, I don't want to see Celsius, I'm only going to work with Kelvin. Do not make that mistake. It's a really stupid mistake, but it can cost you a lot on your test. Never use degrees Celsius, it has to be converted into Kelvin. So 25 degrees Celsius, convert that into Kelvin. So degrees, Kelvin temperature is going to be 25 degrees Celsius plus 273, and that's going to be 298. So our Kelvin temperature is 298 Kelvin. Okay. And then our final conditions is pressure is decreased to 0.5 atmosphere. And its volume is increased to 6 liters. And it says find its new temperature in degrees Celsius. So use the combined gas law. P1 is 1 atmosphere. V1 is 3 liters. T1 is 298 Kelvin. P2 is 0.5 atmospheres. V2 is 6 liters. And our final temperature is T2. So what you're going to do is you're going to go ahead and solve for T2. So, you know, simple math, multiply this, divide by that, and then you can flip, you can do whatever you want. Just basically solve this equation, okay? And then you're going to get T2. Now, I don't know what T2 is. Let's just say T2 was 300 Kelvin. All right, I don't know what, that's probably wrong, okay? But once you get your final temperature, remember you have to subtract 273 degrees and go to whatever you, go back to Celsius, because the answer, it says find its new temperature in Celsius, not Kelvin. So you get the final temperature. If it was 300 degrees Kelvin, or 300 Kelvin, and it's not, remember, convert back to degrees Celsius, and that's going to be your final answer, all right? Okay, number 3, a gas has a pressure of 1,520 torr, a volume of 500 centimeters cubed, and a temperature of 90 degrees Celsius. That's the 9. My handwriting's terrible. Okay, so 90 degrees Celsius. Its new pressure is changed to 3 atmosphere, and its volume is changed to 3 liters. Calculate its new temperature. Okay, so original conditions, pressure is 1,520 torr. Volume is 500 centimeters cubed. Centimeter cubed is also 1 centimeter cubed is also 1 milliliter. So I'm just going to go ahead and write that. So 500 milliliters, and temperature of 90 degrees Celsius. Convert that into Kelvin. How do you do that? 273 plus 90 is equal to 363 Kelvin. Okay. 363 Kelvin. And our final conditions, its pressure is decreased to, it's changed to 3 atmospheres. Now, you have a problem. Our original pressure is in torr, and our final pressure is in atmospheres. So what we're going to have to do is convert our final pressure to the units we want, and that is torr. So remember, all our units have to be the same. So you're going to have to convert 3 atmospheres into torr, and that is going to be 2,280 torr. Okay. Alternatively, you could have converted the original pressure into atmospheres. Both work, but I'm just going to go ahead and do it this way. Remember, the units of your original pressure, volume, and temperature has to be the same with the units of your original pressure, volume, your final pressure, volume, and temperature. If it's not, then the answer is going to be wrong. And also, very important, temperature has to be in Kelvin, not degrees Celsius. Okay. So its pressure is changed to 3 atmospheres, which are converted to torr, and its volume is changed to 3 liters. Our original volume we had in milliliters, so we're going to go ahead and have to convert our final volume into also into milliliters. 3 liters is 3,000 milliliters. Okay, and we're looking for temperature, so we can go ahead and use our equation now. P1 T V1, sorry. T1 I don't know if this is off camera. I'm just going to do it here. Equals P2 V2, this is torr, over T2. And again, just, finesse the math and then get your T2. and that's going to be your answer. And since this question says just calculate its new temperature, you could leave it in Kelvin, or you could go ahead and convert back into degrees Celsius. It's up to you. But combined gas law, it's pretty simple. Just remember, use your chart, read the question more than once. Kelvin, okay, not Celsius, Kelvin, very common mistake. And just be careful, and it's honestly quite simple.